Good day, everyone, and welcome to where we are putting together solutions in those math and science areas that pupils are getting problems with. This video deals specifically with CSEC Mathematics and the past paper questions on the topic vectors. We will be dealing with the years May 2014 until 2018, those 5 years in paper 2. So feel free to like the video and add any comments down below so we can help you in any areas of math or science that you are getting problems with in both the CSEC or CAPE levels. Remember to look at the description down below. It gives all the links to the order in which you should be studying these videos so that you can get a higher grade in your CSEC math. Let's look at the major topics in CSEC math, and we can see that there are 10 of them, and this video deals with the 9th one, vectors and matrices, and specifically the area of vectors. Those two topics combined as question 9 comes as one full question in paper 2. It's actually the last question on the paper with 12 marks out of the total of 100, and 4 multiple choice questions are tested on this area, 4 out of 60 in paper 1. This video deals with 5 years from 2014, in which the paper was just as the years from before, as you can see in our last video on this topic. And from 2015 until 2018, there was a change. The paper now became such that spaces were provided for students to write their answers on the examination paper instead of a separate examination pad. May 2014, number 11C, the last question on the paper. In the diagram below, the coordinates of P and Q are 2, 4 and 8, 2, respectively. And we can look at our diagram and we can see both of them lie in the first quadrant. The line segment joining the origin O, 0, 0, to the point P may be written as the vector OP. What term is used to describe OP? Well, if we recognize that there's an arrow above the OP, it means to say it's not just a line from O to P, but it also gives us the direction. So it is that we're starting from O and we're heading in the direction to P. So we can describe this as a position vector because it tells us exactly where P is located in reference to O. Part 2. Write each of the following in the terms AB, meaning to make it look like a column vector. So OP was given as 2, 4, written as a row vector. To convert it to a column vector, we just put the x value on top, 2, and the y value below, 4. And there is no comma here. There's no division sign. Those are two separate components. And OQ, well, that will be similarly 8, 2. Part C. What is PQ? So let's do a little bit of working. If we consider how do we go from P to Q, and I'll put a little purple line here moving from left to right. Well, the way to pass, we can pass from P to O, and then we can go from O to Q. So PQ is equal to PO plus OQ. And if we double check where we wrote our little statement, we can see that the inside letters are the same. They are both O. So it's stating that we walked from P to O, we took a rest, and then we started back at O and went to Q. So let's see what we can substitute. Now we don't have PO, but we have OP. OP means we're going in the direction from O to P. We want to go in the opposite direction. So how do we deal with that? We put a minus sign. So PQ is equal to minus OP plus OQ. And we can now substitute. That will give us minus, in the brackets, 2, 4, which we got from part 2A, plus A2, which we got from part 2B. And we can solve. Minus 2 plus 8, if we work out the x values, will give us 6. And the y values, minus 4 plus 2, will be minus 2. So PQ is 6 minus 2. And if we think about it, that means to say that if we start at P and we want to head to Q, we must move 6 units to the right and then 2 units downwards. Now, we go to part 3. Given that OP is equal to RQ, determine the coordinates of the point R. So if OP is equal to RQ, and let's draw another purple line there, we're sliding it downwards, so it's a sort of translation. Then we want to find the point R, so we want to find OR. So how do we go from O to R? We can go from O to Q, walking from there, O, ending up at Q, taking a rest, and then we start back at Q and we head to R. So we head a little downwards to the left. Now we know OQ, that's given already, but what is QR? QR, it's the same as, well, it should be minus RQ, sorry. So minus RQ, and we know RQ is the same as OP, they're parallel. So we can substitute. So OR is equal to 8, 2 minus RQ, 2, 4. And that will give us 8 minus 2 is 6, and 2 minus 4 is minus 2. So the coordinates of R will be 6 minus 2. And for part 4, state the type of quadrilateral formed by PQRO. And since we know that OP is equal to RQ and OR is equal to PQ, thus the quadrilateral is a parallelogram. May 2015, number 11b. The position vectors of the points R, S, and T relative to the origin O are minus 3, 4, 1, 1, and 5, minus 2. Since they didn't give us a sketch in this diagram, we will make one. Let's put in the X and Y axes, and the point of intersection where they meet would be O, the origin. Now what is R? Minus 3, 4. So it means if I start at O and I go with my yellow arrow 3 units to the left, and then I turn 90 degrees and head 4 units up, that point will be R. So we'll indicate OR with a red arrow to show us it's going up to the left. Now what about OS? OS is 1, 1. So we move 1 unit to the right, 1 up, so that'll give us OS. And similarly for OT. T is 5 minus 2. So here we have it. Part 1. Calculate the value of modulus OR of the vector. What that means, those two signs coming down on the side of it indicates that we need to find the length, or how long is the vector OR. Is that the red line on the left? Well, it's difficult to measure that is because this is a sketch. But what we recognize is there is a right angle triangle. And if there's a right angle triangle, we know 3 and 4 already, right? Those are the two short sides. So the longest side, called the hypotenuse, is what we need to find, its length. And there's a rule for that, Pythagoras theorem, which is O squared plus A squared, the two short sides, the squares of them. When you add them up, it will give you the longest side, H squared. So if we substitute, we'll get minus 3 squared plus 4 squared is equal to H squared. Minus 3 squared minus 3 times minus 3 will be plus 9. 9 plus 4 4s are 16. 9 and 16 is 25 is equal to H squared. So if I want to find H, carry the square across, and the opposite of square, or the inverse of square, is square root. So the square root of 25 is equal to 5 units. And that tells us the magnitude or length of the vector OR. Part 2. Express in the form xy, a column vector, the vectors RS and ST. So let's look at RS. See what happens on the sketch. For us to go from R to S, we can pass from R and head to O, and then from O, we can head to S. So we got our first line, RS is equal to RO plus OS. Now, we don't know RO, but we know the opposite of it, which is OR. They gave us that, minus 3, 4. So we can substitute for RO by stating that RS is equal to minus OR plus OS. It's the same length, it's just the opposite direction. So now, RS, if we substitute, will be minus of minus 3, 4 plus 1, 1. And if we work out the x values, minus minus 3, that will give us 3 plus 1. 3 plus 1 is 4. And minus 4 plus 1 is minus 3. So RS means we're going 4 units to the left in the x direction and 3 units up. Now, let's see, what else can we say? For ST now, to go from S to T, we move from S to O. and then we go from O to T. So we don't have SO, but we have OS. So that will be the negative of it. So if we substitute, we get ST is equal to minus OS because it's the same length but the opposite direction, plus OT. So that means that if we substitute, we get minus 1, 1 plus 5 minus 2, minus 1 plus 5. If we're solving, will give us 4, and minus 1 plus minus 2 is minus 3. And you can double check this with your calculators. Now, what that tells us that if we are moving from R to S, we would move 4 units to the right and 3 down. And if we're moving from S to T, it's the same thing. 4 units to the right and 3 down. Part 3. Using the results of combining the vectors in B, RS and ST, justify that RS is parallel to ST and that RST is a straight line. Well, since RS is equal to 1 ST, because both of them is equal to 4 minus 3, that tells us that they are scalar multiples of each other. And they also share a point. The point is S. So if you're a scalar multiple of each other and you share a point, then the three of them form a straight line. R, S, and T is a straight line, or we can say they are collinear. May 2016, number 11A. The position vectors of points A, B, and C relative to the origin O are OA is equal to 2 minus 2, OB is equal to 6, 1, and OC is equal to 10, 4, respectively. Now, they didn't give us a diagram, so let's make a sketch. X and Y axes, and the point of intersection will be O. And we know OA is 2 minus 2, so start from O, move 2 units to the right and 2 units down. So we have A. And for OB, 6, 1, 6 to the right, 1 up. And C, 10, 4, 10 to the right, and 4 up. So we have a general idea, because this is a sketch, this is not exact to scale. A general idea of where A, B, and C lie. Now, in part 1, A, expressed in the form of xy as a column vector, the vector AB. So, let's take a look at going from A to B. Let's use a purple line. So how can we pass from A to B? We can go from A to O, and then O to B. So AO is minus OA, same length but opposite direction. So we need to put a negative sign, plus OB. Let's substitute for OA and OB that was given above. So AB is equal to minus 2 plus 6, 1. Let's work out the x values. Minus 2 plus 6, that will give us 4. And minus 2, that is 2. Plus 1 is 3. So AB is 4, 3. Meaning if we start from A and we want to go to B, we need to move 4 units to the right and 3 units up. So it's sloping upwards to the right. And it follows our sketch. Let's look at AC. To go from A to C, we go from A to O just as before, and then from O to C. Now let's substitute. AO is minus OA just as we did in part 1. And we're adding OC. So let's substitute minus 2 plus 10, 4. Minus 2 plus 10, let's look at the top, will give us 8. Minus 2, that is 2 plus 4 is 6. So we know AB is 4, 3, and we know AC is 8, 6. So part 2. Hence, determine whether A, B, and C are collinear, giving reasons for your answer. So since AC is equal to 8, 6, which is really, we can extract 2 from it. If we factorize it out, we'll get with 2 brackets 4, 3. So AC is equal to 2 brackets 4, 3, which is AB. So we can say AC is equal to 2AB. Then, what does that tell us? It tells us that AB and AC are scalar multiples of each other because one is twice as long as the other. And they also share a common point, and the common point is A. So they're parallel, and they're multiples of each other, and they share a common point. So A, B, and C lie on the same line, meaning that they are collinear. May 2017, number 11C. The position vectors of the points P and Q relative to an origin O are OP, which is equal to 4, 3. So that means if we look at our sketch, from O we move 4 units to the right and 3 units upwards. So we get the general slope there from O to P. And OQ is 5, 0 respectively. We start from O and move 5 units to the right, and that will be on a flat line. That will give us Q. The diagram below shows that PR is equal to 3OP. So what does that mean? It means the length from P to R is 3 times longer than the length from O to P. So we can say, let's put values there, 1 to 3. And similarly, the same for QS. Expressed in the form XY as a column vector, OS. So what do we know? We know OS would mean that it is 1 and 3, 4 times longer than OQ. So if we substitute, that'll be 4 times 5, 0. And let's work it out. 4 5s are 20, 4 zeros are 0. So it's 20, 0. Good. Let's go to the next part. Find for PQ. Well, if we want to go from P to Q, we can pass from P to O and then O to Q. And what's PO? Minus OP plus OQ. So that's, if we're substituting there, minus 4, 3, which was given above, plus 5, 0. And if we're working out calculating the x values, minus 4 plus 5, that's 1. And minus 3 plus 0 is minus 3. And the third vector we have to find for is RS. So how do you go from R to S? We go from R to O, and then we go from O to S. Now, let's write that RS is equal to RO plus OS. And if we substitute, RO is minus OR. Same length, opposite direction. So minus OR plus OS. And we now substitute. So we get, now let's recall that OR is 4 times OP. Just like how we did OQ to OS. So OR will be 4 times 4, 3. Which is 4 4s are 16, 4 3s are 12. So OR is 16, 12. So we can now use that. So RS is minus 16, 12 plus 20, 0 OS, which we got in the first part. So minus 16 plus 20, that'll give us 4. Minus 12 plus 0 will be minus 12. So let's state two geometrical relationships between PQ and RS. So if we look at RS, we can factorize out 4. So RS will be 4 brackets 1 minus 3. And what is 1 minus 3? That's PQ. So we can say RS is equal to 4 times PQ. So let's give two relationships. One, that PQ and RS are scalar multiples of each other. One is 4 times longer than the other. And of course, because they're vectors and they're scalar multiples, that means they are parallel. May 2018, number 11b. The diagram below, not drawn to scale, shows a quadrilateral ABCD, in which the vector AB is equal to M, DC is equal to 3M, and since one is 3 times longer than the other, it means that they're definitely going in the same direction, and AD is equal to N. Part 1 of the question. Complete the statement below on the geometric properties of the following vectors. Vector AB and vector DC are, well, we know they are going in the same direction, so we can say that they are parallel. And mod AB, the modulus of AB, meaning the length of AB, is how many times the length of CD? Well, we know CD, the length of that, is 3 times the length of AB. So if I want the length of AB alone, I can carry the 3 across. The 3 is multiplying. When I carry it across, it will divide. So it'll be 1/3 the length of CD. Part 2. Express BC in terms of M and N. Well, how can we go from B to C? We can start at B and head to A, and then A to D, and then D to C. Now let's write that down. BA plus AD plus DC. And if we look at the inside letters, we see A and A, they're the same, D and D, they're the same. So we're really starting at B and we're ending up at C. So we wrote a correct formula. Now what is BA? BA is M in the opposite direction. So that's minus M plus AD, which is N, plus DC, which is 3M. And it now becomes an algebraic expression and we can simplify it. So 3M minus M is 2M plus N. That's BC. Now in part 3, they're telling us L is the midpoint of CD. Find BL in terms of m and n? Well, if we want to find BL, we can go from B to C and then from C to L. So we know BC, but what is CL? CL is minus LC because that direction is going to the right and CL is going to the left. So we put a negative sign. And L is the midpoint. Since L is the midpoint, that means that LC is half of DC. So we can now substitute. BL is BC, which is 2m plus n from above, minus a half of, what is DC? 3m. And we can solve that. Let's put the m's together to 2 minus, what is a half of 3? 1.5. So 2 minus 1.5 is a half m plus n. And that gives us the vector BL. We've now come to the end of this video on CSEC past paper questions, specifically on the 9th topic of the syllabus, vectors. We've already done the first video covering the past paper questions from 2009 to 2013, and this one is from 14 to 18. So our next video will be from 2019 up to the present. Don't forget to look at the description down below in order to get the links for all the topics. And that way you can follow to get a better understanding of how to study this CSEC Math to get a better grade.